Yep. Hello for everyone. This is our lecture 3, week 8. Yeah. So it's a continuation of sequence and series, but mainly it's about sequence. Okay. So first lecture is the defining of the terms and what is the type of sequence. Yeah. Uh, Lecture 2 is defining the limits of the sequence. So and lecture 3, yeah, so we're going to talk about the property of the sequence. So sequence have a property. Yeah, so there are sequence called increased sequence. So sequence can be strictly increased, can be decreased, can be strictly decreased, and sequence can be a constant. So and the sequence can be bounded above, yeah, and some sequence I can bound it below. So some sequence have this type of a property. Some sequence have increase. Some sequence have strictly increased. Some sequence are decreased. Some sequence are strictly decreased. And some sequence have constants. Our constant sequence. Some sequence can be bounded above. Some sequence can be bounded below, or can be a mixture, bounded above and below. So those are the things we're gonna talk about this lecture to 3, week 8. It's about the property of the sequence. So what is an increased sequence and what is a sequence that bounded above and below? So we're gonna discuss this through this lecture. Yeah. So property of the sequence. Sequence can be classified in various ways. Yeah. So sequence can be classified in different ways. So we're gonna start with increased sequence. So increased sequence or increase means the sequence is increased when tn plus 1 is greater than and equal to tn. So what does this mean? It means that the value of the next term is greater than or equal to the previous term. So it's talking about the term. So uh, the first term is greater than uh, the second term is greater than the first term. Uh, but the third term is greater than the second term. So that is the meaning of this meaning. So increased sequence, it's talking about the terms. Uh, so the first term is less than the second term, but it can explain in this way. So the second term is greater than the first. The third term is greater than the second, or greater than or equal to. So remember this sign. So, for example, yeah, like this sequence, the even number or odd number. Even number are 2, 4, 6, 8, 10. So this is the example of the increase sequence. Why? Second term is greater than the uh, first term. Yeah. Third term is greater than the, so it's getting increase. So okay, lay aku dah si term long dua term or dua, going up. So the next term will be greater than 10. So we all know that 2, 4, 6, 8, and 12, so and so on. So this is the sequence. So this is example of increasing. Uh, so if we plot this onto the graph, so we have something like this. Yeah, we have up here this sequence. So you say n is equal to 1, uh, 2, and then 4. If we plot the points, it will go like this. So mainly it's all about the term. So increase means the second term is greater than the first term and so on. Uh, so it's going up, the terms are going up, getting higher or equal. It can be say that 2, 4, 6, 6, so it's greater than and equal. So that is the meaning of increase sequence. Uh, but what is strictly increase? So the value of the next term is greater than the previous term, but no equal. So for example, 1, 4, 9, 16, 25. Yeah, after 25, then what? 36. Uh, yeah, or 1, 4, 27, 2, 156. Uh, so, example, mayo or strictly increase. Equal. They have to give me a little classify. The difference. Yeah. If I need a difference, porque que leio difference, kama is a difference e. So having increase a term. So that's it. Meaning of strictly increase. Kama whatever this term, I had one I don't. So if I pay you to a graph, kama na de, my sa o I don't. Strictly increase. I pay the increase. I pay for a cow curve on the graph. I pay for a same the difference. I pay the the strictly increase. Qua is a difference or value. Yeah, pay in other words, increase means greater than and equal, but strictly increase means greater than. So the same meaning fine with fear or come at it. Yeah. So this is example of strictly increase. So increase means greater than and equal, but strictly increase means greater than. Uh, or means the difference between the terms or the ratio between the terms are getting higher. It's uma difference o kama vai sa o mereka sifai va su wong su warko wong o kwa ke le ale me. Aku sih boleh graph pi kau pi kau straight line. Ah, yang ngah. But the best difference are strictly and increase strictly increase and increase. Increase is greater than or equal, but strictly increase is greater than, but no equal. Yeah. So decreasing, when the sequence is decreasing, that Tn plus 1 is less than Tn, means that the value of the next term is less than or equal to the previous term. For example, this one. So increase going up after 1, then 2, 3, 4. But decrease going down. So after 1, then the next term will be less. The next term will be less. So fangasa or meaning of so decrease means the value of the next term is less than or equal to the previous term. So term 2 is less than term 1, or in other words, term 1 is greater than term 2. But only increase, term 2 is greater than term 1. But decrease, or the term 1 is greater than term 2. In other words, the increase going up, but decrease going down. The value in the sequence is going down. So if we draw a graph or plot a point, so something like this will happen. So the points will go down like this. Because we start from n is equal to 1, n is equal to 2, so the value of an or tn is going down. The value of the term is going down. So decrease is less than and equal to the value of the next term is less than and equal to the previous term. So it means T1 is greater than T2. But increase T2 is greater than T1. So that's decrease. But strictly decrease. The sequence strictly decrease when Tn plus 1 is less than Tn. So it means that the value of the next term is less than to the previous term. So for example, negative 2 over 3, negative 5 over 4, negative 2, negative 7 over 6. So kay kusala mare same as increase. So decrease means less than and equal, but strictly decrease less than. So it cannot be equal. So it's all about the nature of the term in the sequence. So that's the difference between strictly and decrease. Strictly decrease and decrease. Yeah. So according to the graph, so something like this. Yeah, pick out smoothly the decrease. Yeah. So the sequence is constant when Tn is equal to C. So in other words, it means that the value of the next term is equal to the previous term. So for example, something like this. So this is called a constant term. The term in the sequence never change, constant. So it's all the same. So this is meant by the constant sequence. So this sequence is constant, cannot be changed. Or the other or T2 cannot be greater than T1 or T1 cannot be greater than T2. So constant term T1 is equal to T2, T2 is equal to T3, T3 is equal to T4, and so on. So in terms of graph, if we draw the graph of this sequence, so you have a straight horizontal line. So we have a straight something like this. So the points will align at the same line. So that's the constant sequence. So decrease, increase, strictly decrease, and now constant sequence. Yeah. And then so means that the value of the next term is less than and equal to upper bound. So this value, you the term in the sequence cannot be greater than. They all less than like this value. So this is mean bounded by above. So there is a value, or in other words, in terms of limit. So there is a value that this sequence cannot be. That's the limit. So in other words, so there is a value above that this sequence cannot be over. So if the u is 2, if you sub in whatever value of n, this the term of this sequence cannot be say 2.1, 2.2. It's always below 2 or 2. So if you sub in the value of n into the sequence, and term will say 2.1, so that's wrong. So this sequence is bounded by u, so it cannot be have a 2.1, only 1.999 or 2, 1.89. So value like that. So bounded above means there is a value, the higher value that this sequence cannot be over, or in other words, there is a limit of this sequence. So the limit of this sequence is u. Yeah. So, for example, this sequence negative 1 over 3, 1 over 3, 3 over 5, 5 over 6. Yeah, if we graph this, these are the points, but the line here, this is the u that this sequence cannot be bound over with. So, using that u is equal to this sequence. It cannot be say so it's always less than 2. Or we can apply the limit of sequence here. If n's increase or going to approach infinity, so therefore the sequence approach 2, or the limit of this sequence is 2. So we can say this 2 is a limit of this sequence. It cannot be over that 2. Yep, so that's bounded above. So higher value. If we have some higher value, so that the sequence cannot be over with, go over with. Sequence bounded below when Tn is greater than so it means that the value next to the term is greater than and equal to b. So this b is the lower boundary. So bounded above, so there is a value in the top, so it cannot be over with. So bounded below, so the value below, so that we cannot be cannot be, yeah, in other words, greater than. So it's always b or equal. So bounded below la, o le value le piko dal, e le whenga sopo ia. But bounded above, e value le piko nua, e le whenga ala koe nua. So le bounded below, o le value le mo lalo. E le whenga sopo ia, o le value mo lalo, o le value mo lalo anga. So above, o le value mo runga anga. Below, o le value mo lalo anga. So below means this is the lowest value of this sequence. It cannot be cannot be greater than this lowest value. So pinga so above cannot be over that too. Below cannot be lesser than that value below. So fa winga apa o value mo runga nga lim fenga sopo ia. Fa winga below o value mo lalo anga e ko isi value mo lalo. So fa winga fenga fianga meio bounded below. Sala au the u for upper bound, the b da fa nga i below. Yeah. So for example, 4 over 3, 4 over 9, 4 over 27, 4 over 81. So if we graph this, yeah, we have something like this. So this means it cannot be go lower than 0. So according to the graph, the sequence is bounded below at b is equal to 0 as n increases. So whatever value of n going to infinity, this will always be the lowest value is 0. So it cannot have a negative value. It will be 0.000001 or 1 times 10 to the power of negative 100 in other words. So if you sub in the value of n, when n are getting higher, so it cannot go lower than 0. It's always 0 is the lowest value of this sequence. So may I have point above, above. So la po o ya value nga, ay pa ni pelo. O value like kiki ang sequence nga, ele finga o nga like ele finga dua ku kede jam. Fa wi ngpe nga ay pa above. O value la po nga ele finga over ku nga. So if I'm boundary below. So in terms in other meaning, if we apply our limits of sequence, so the limit of this sequence from below is 0, but the limit of this sequence from above if we run above is 2. Kung nga may papinga. Yeah. So yang sisingalang boundary below. So it's all about lowest value and over value that is the highest. It cannot be over that u. So boundary below. So this is value of p. This is the lowest value. For example, this is 0. This is the lowest value. Is 0. Cannot be a negative. So that's the meaning of bounded above or bounded below. Or in other words, there are limits of this sequence when go higher, and there are limits of this sequence when go lower. Yan nga. Yeah. So example 1. Prove that this sequence 2n plus 1 over n squared is decreasing sequence for all value of n. Yeah, n is a natural number. Yeah, let's prove. So decrease. Sequence is decreasing if, so decrease not strictly increase. Not strictly decrease is a decrease. So we use this symbol. So tn plus 1 is less than and equal to tn. Yeah. Or tn is greater than and equal to tn plus 1. So therefore, yeah, what happened here? We make this side equal to 0. So we minus cn both sides, and then we have something like this. So tn plus 1 minus tn is less than or equal to 0. So tn, so the general term of the sequence is 2n plus 1 over n squared, and tn plus 1. So no more n. We are substituting the new value of n is n plus 1, and that's why we have this. So we will be placing n by n plus 1, and that's why we have this. So if this is tn, so this is tn plus 1. So we're placing n by n plus 1, and then we have like this. And then, so we expand. Then we have something like this. 2 times n, and then times 2 plus 1 is equal to 3, and then our Fourier method, and then we have something like this. And sub into the equation. What equation? This equation. So we sub this value of tn and this value of tn plus 1 up here. And then we have something like this. So this is tn plus 1 minus tn is less than or equal to 0. Yeah. So continue solving. So we cross multiply or envelope because of the fraction envelope. Yeah, and then we have this answer. So we multiply this by this one, and we multiply by this whole thing by this one, then we have something like this, and then we multiply the denominator, and then we have something like this. And then multiply the denominator will be multiplying this denominator by the 0. So anything cancel out this denominator, and 0 multiplied by this. After we explain. Yeah, I don't know. if this is right, but you go check. Yeah, after we expand and simplify, and we have something like this, and then factor out the negative. So this negative, factor out, and then we have something like this: 2n squared plus 4n plus 1. After we factor out the negative, then we sub in the value of n is equal to 1 and n is equal to 2 to prove that it is less than 0. So if we sub in 1, if we sub in 1 and then we sub in 2, what will happen? Yeah, so if we sub in 1, so we have a negative 7. Sub in 2, we have a negative 17. Is this proof that this value is less than 0? Yes, negative value. That means it's always less than 0. So therefore, this is proof that this sequence is decreasing because 2n squared plus 4n plus 1 is always less than and equal to 0. So and that's why you need to know the difference between strictly increase and strictly decrease and increase. So for solving this type of questions, for proving. Yeah. And then example 2. Classify the following sequence as increase, decrease, convergence, divergent, oscillating, and constant. So increase, decrease, convergent, divergent, oscillating, and constant. Some of these sequences may have more than one classification. So it can be, for example, it's decreasing divergent, convergent, or divergent oscillating. It can be mixed to classify the sequence here. And then solution A. So 1 over n. If we the best method is to sub in some value of n. Maybe n is equal to 1 up to n is equal to 10, and look at the value. What is happening? So this is what happened if we sub in the value of n. 1 over 2, 1 over 3, 1 over 4, 1 over 5, and dot. Maybe this is what happened if we sub in 1000. N is equal to 1000, so 1 over 1000. Therefore, this sequence decreases and diverges to 0. So what is the meaning of diverge again? There is a limit of the real number. So the limit of this sequence is 0, but it's decreasing. According to the value, it's decreasing, going down, decrease. So move sắc or decrease. Yeah, or converge. So converge to 0. So the limit of this sequence is 0. There cannot be a negative value if we sub in some value of and it always be a positive value, but it's getting closer to 0. Yeah. B 3 minus n, so we have 2, 1, 0, negative 1, negative 2. If we sub in some value of n, we start to 1 and then 2, then 0. Then 1, 2, 3, 4, 5, 6, up to infinity, and then we have this sequence. So therefore, this sequence strictly decrease and diverge. So diverge means there is no limit, or in other words, the limit is negative infinity. What does that mean? It's going lower. What is the lowest value? It's negative infinity. So there is it's diverged, so no limit. So, but it's diverged to negative infinity. So if we got diverged, no limit. If we got add y, yeah, y, lalo. Ni dua po finga kamay dan. Mình phải diverge to negative infinity. Pada alphabet foi la kunga kami de luo negative 2 no inga lai convert. Ya nga. So an mele ya luo sequence dia asa pagi value of n is equal to 1000. If we sub n is equal to 1000, so 3 minus 1000, we have negative 909 997 or 997. If we sub in 1000, so it's going down or strictly decrease. Now, yeah, so strictly decrease means pusapi average strictly decrease diverge means going to negative infinity. IP average decrease say value like decrease converge. So this is where I say strictly increase and decrease. Yeah. So strictly decrease means arusak o lalu ide ngaka. Alphabet decrease. Say decrease. IP say melai ngaka mai nang decrease. So si ngah laying on the dua decrease, but strictly decrease. Yeah. So decrease means there is a value that converts to this decrease, but strictly decrease means diverge. There's no limit. It's going to negative infinity. Yeah. And then C, negative 1 over negative 1 to the power of 2n. So if we sub in some value of n, then we have something like this. 1, 1, 1, 1. Negative 1 to the power of 2, negative 1 to the power of 3, negative 1 to the power of 4. It always have a positive 1. It cannot be negative. Because 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. So it cannot be negative. It's always positive 1. So therefore, this sequence is constant. Why? All terms in this sequence cannot be changed. It's the same value, and that value is 1. So therefore, this is a constant sequence. What about cos n pi? So if we sub in some value of n here, then we have some. So 2 pi cos pi or cos 180, cos 2 pi, cos 3 pi. This is happening. Negative 1, 1, negative 1, 1, negative 1, 1, and so on. So it's a repeated. So it's a negative 1, 1, negative 1, negative 1, 1, and so on. So therefore, this is a sequence, or this sequence is oscillate or alternate. Oscillate, going up, down, negative 1, up to 1, going down to negative 1, up to 1, going down to negative 1, and so on. So oscillate. But this oscillate have a boundary. What boundary? It's always the lowest value is negative 1, and always the highest value is what? Is 1. So it's bound by negative 1 and 1. It cannot be 2, or it cannot be negative 1.5. So that is mean it's oscillating, but it's bound. Means it only stop from 1. It cannot be over from 1. It cannot be lower than negative 1. So that is the meaning by D, bound by negative 1 and 1. Yeah. And that's how we identify the sequence property. So the easiest way is to sub in the value of n into the general formula, the Tn, and then by inspection, look at the value. What is happening? If it hard for you, then plot the point onto the graph and identify that type of sequence, or that kind of sequence. Is that a decrease or increase? Same as I say in lecture 2 week 8. Finding the limits of the sequence, the best method is the graph. So I will also tell you in this finding the type of sequence, either decrease, degree, increase, degree, decrease. So therefore, graph is the best method. So now you know uh, decrease if there is a if that sequence has the limits, decrease to the limits, but strictly decrease when it decreases to infinity, negative infinity. Uh, yeah. Then example 3, find the least boundary, least upper bound. Yep, so form with LUB and the greatest upper bound, so form to GRB of the sequence. What sequence? This is the general term of the sequence. So find the LUB, least upper bound, and the GRB, the greatest lower bound. Yeah, how to find? Yeah, solution. Best method come into your mind. Sub in some value of n. Start from 1 up to whatever value you want. Yeah, if you sub 1, we have 3, 2, and 3, 4, 5, and so on. Yeah. So you can determine by looking at this value. How was the sequence? Is going up or going down or oscillate? Or is any boundary from above or boundary from below? Oh, those are the things you need to consider. Is this a sequence decrease, increase, converge, diverge, or any boundary from above or any boundary from below? But the question is, find the what? LUB, the least upper bound and the least the greatest, the least upper bound and the greatest lower bound. Yeah. So after we sub, and then we have something like this. So the thing is, and the best method I always told you, the graph. Try to graph this sequence. Wow. Yeah. So we're gonna take let's say n is equal to 35. So these are the points start from here to here. So this is the graph of this sequence, adding some new terms, and then we have something like this. Yeah. So, and then try to draw a line here and a line here. So according to the graph above, the upper boundary is shown by the red line and the lower boundary is shown by the orange line. So if we zoom in, so this red line is free. This yellow line is 2. So therefore, the lower upper bound is what? 3. The greatest lower bound is what? 2. So upper bound, lower bound. So means this sequence. What sequence? This one. 2n plus 1 over n cannot be go higher than 3 and cannot be go lower than 2. So the highest value is 3 and the lowest value is 2. So if you try to sub in whatever value of n up to infinity, it cannot, there is no value in the sequence, say 3.1, or can we say 1.9. So it's always say 2.0001, and the highest value is always 3. So we always notice in the first time we sub in some value of n. So this is always the highest value. So it's 3. If we continue subbing the value of n, then it's going to decrease, and that decrease will be stopped from 2. So and that's why we have this final answer here. So the least upper bound of this sequence is 3, and the greatest lower bound is 2. So the best method is the graph to find the lower bound and the upper bound. Yeah. So do tutorial 9.3, number 11, number 1 to number 11, page 120 to 122 of the course reader. And I post this exercise on Moodle. So it's called chapter 9 sequence. So I post this part of the course reader for those who don't have the course reader to look through the exercise. So no more excuse. Course reader is now on Moodle. Yeah. And remember our motto: don't stress, do your best, forget the rest. Yeah. And that's our lecture 3 week 8. And I'm sorry for the late posting. Yeah. And that's our lecture 3 week 8. Học chay mình vía lễ Easter chay out so far so forth.